starting prove your grade, because I'll give you a grade based on what you did. So if you get, if there's 8 questions and you get, 6 right, you'll get a 6 out of 8. So you can always make sure that you go back and you look at your, good morning, you look at your, any questions on that? You guys good on that? Okay. All right, let me finish doing this. Okay, so we got Jonathan. Oh, Lyneth, you were new. Is Lyneth here? No. And Corbin. No. Okay. All right. We got Haley. We got Lisa. We got Emily. Mamie. Jade. Jamie. Okay, so for those of you in Zoom, talk to me. How did it go yesterday or on Tuesday? Did it work for you? Was it hard to follow? Could you hear me okay? Let me know what your thoughts are.
I had no issues.
Okay, thank you, Emma. Anybody else on Zoom?
Was it like in regards to the actual Zoom meeting, like with audio and anything like that?
Yeah.
It went really great.
Okay, good. So that's how we'll do it, as much as I can. And I apologize to the Zoom people. I forgot my cord on Tuesday, and so my battery died. so that's why I just kind of went, oh, see ya, we're done. So I apologize. We only went maybe another 10 minutes, and then we left for the day. So for those of you who missed it, I had to, oh my gosh, don't talk about it. I had to put my dog down on Tuesday after class. So that's why I had to leave early. She was 12, she was my baby, and she had a good life. She was very well loved, so that's good. But man, those dogs, they get under your skin. I was sweeping this morning and I found her Kong and like, oh gosh. Let's not do that anymore. So anyway, it'll be a process, I know, but yeah, you think, oh, it's just a dog, and it's like, no, she was a family member. Yeah. Well, and my daughter said, she goes, Mom, I actually like Katie more than some of our family members. So there's that. Sad to say, but true. So thank you all for your comments. Yeah. So, okay. So what we're going to do today is we're going to continue on. Let me share my screen. We're going to continue on with fractions. And so let me turn this light on. On Tuesday, we kind of got started on fractions, and what I don't want is and you can open that if you need to detail one.
Oh, it's great.
Does that work better back here?
Yeah, it's just easier for me to see too.
Oh, okay, the distance thing.
Yeah,
okay. Okay, gotcha.
Thank you.
Oh, of course. Okay, so Delaney's not being rude. She just can't see. She just can't see. I don't want to be near you. Okay, so when we're dealing with fractions, we talked about on Tuesday just a little bit. Zoom, again, my battery died and I didn't realize it till it was too late. When we're doing them on the homework, and so some of you that turned it in already, you need to go back and show me your work. I don't want you to use your calculator. I want you to really understand why fractions work the way that they do. So let me move all this stuff so I can write. Yeah, that works better. Okay. So if we take let's see, we're not going to do this. I'm sorry if I'm making you sick. Okay, so we have 3/8 and 3/4. All right, now how do we get, and anyone can answer this, how do we get 3/4 out of this one? How did that happen? If this is 3/8, that makes sense. There's 3 colored out of the 8. How does this one right here become 3/4? How would we write that and then get the 3/4? Okay, so Jonathan said it's 6 out of 8, and then you reduce. So that's correct, right? There's 6 equal parts. And that is the key with fractions, is it's all about the bottom number. And the bottom number, it tells you how many parts you're looking at. The top number tells you, excuse me, let me say that again. The bottom number tells you how many parts there are in the whole. The top number tells you how many parts we're looking at. So what happens with fractions is a lot of times people freak out and they don't understand the concept of a fraction. They just know that there's a lot of rules and a lot of ways to do it, and it's really confusing. And so you jump to the calculator and let the calculator do all the process. So what I want you guys to be able to do is be able to do fractions in your sleep. What I look at fractions as, they're just baby numbers. They're little numbers. That's all. They're parts of a number. They can be whole numbers plus another part, but they're just part of the whole number system. And this is the honest to God truth. Growing up, I knew how to manipulate the numbers and how to add them and subtract them because I memorized the steps, but I didn't understand why I had to do what I did. So it wasn't until, this is really sad, it wasn't until I was teaching high school math, and I was tutoring, and I was having to tutor students who, were very, very low level math. Like they barely got through 4th grade math. And so after school, I was tutoring them. All of a sudden it clicked for me. It was like, oh my gosh, now I understand why I have to get, a common denominator and the process of getting a common denominator. So it makes a big difference when you're able to actually see the process, see a visual of it, because some of us are going to be visual learners. I'm really hot. And then be able to turn it into something else. So when we're looking at the top number, right? The top number is 6, the bottom number is 8. Whenever we're talking about reducing, what we're doing is we're dividing. That's what reducing is. It's just division. That's all it is. You have to divide by the same number. So if I'm dividing by 2, because they're both even numbers, I know 2 will go into both of them. If you notice here, and we talked about this on Tuesday after the Zoom broke down, this number right here is 1. So I'm dividing by 1. This is super powerful because when I multiply by 1 or divide by 1, I'm not changing the value of it. I'm just changing how it looks. And so it's kind of like when you have someone named Robert, right? One person. I can call him Bob. I can call him Bert. I can call him Rob. Lots of different names for the same person. Same exact thing with fractions. This is one name. 6/8 is one name. If I divide by 1, 6 divided by 2 is 3. 8 divided by 2 is 4. Same exact value as this. Same exact value. So if I were to do this and take out this line right here. Yeah, take out that line right here. Do you see how now I have these big pieces? I don't know if I can change the color of it. Let's see. Anyway, so I have this piece right here. I have this piece right here. And I have this big piece right here. So look, I have 3 pieces out of the total 4. So it's exactly the exact same size piece. I'm looking at the same thing. 6/8 is Robert, 3/4 is Bob. Same person. Okay, so being able to divide or multiply by 1 is going to be very, very powerful for you. Okay, so we're drawing. All right, so now we're looking at what's called an improper fraction. So an improper fraction, all that means, so these are just terms that you're going to need, and I'll use them. So an improper fraction just means top heavy, which means it's more than 1. Could be more than 2, more than 3, more than 4. But that's all it means, is it's a whole plus a little bit more. So on this one, again, we're looking at the blue, right? So I have 8 pieces here and I have 3 pieces here. Well, the bottom number is how many total pieces we're looking at we have in each circle. The top number is how many are colored in. So 8 plus 3 is 11. So you can see this is the same as 1 whole and 3 left over. So 1 whole and 3 left over. Now, you can see it visually, but mathematically, how do you go from here to here? Well, you just divide. This fraction line just means division. That's all it means. So if I were to actually do a division problem, so it's 11 divided by 8, right? Going all the way back to what grade is that? What, 3rd grade division? So 8 goes into 11 1 whole time. 1 times 8 is 8. I subtract, I have 3 left over. So this 3 left over goes up here. It's your numerator. So it's 1 and 3 out of 8. So the fraction line just means division. That's all it means. All right. So if I had 25 out of 3, how would you change that to a mixed number? So this is improper. This is called a mixed number because it's got whole numbers and fractions. So what would 25 over 3 be? So 25 divided by 3. So 3 goes into 25 how many times? 8 times. Good. 8 times 3 is 24. I subtract and I have 1 left over. So this is 8 whole and 1 out of 3 left. So this is a part. This is, and the part is the numerator because that's how many are left over. So that's your top number. This is the denominator. This is your down number. And this is your whole number because 3 goes into 25 8 whole times. Okay. All right, so that's kind of the setup of fractions. When we're, okay, we're not going to visually depict. All right, so we're going to start with adding, and you guys in class we already did some of these, but that's okay. We can practice again. All right. So when you're looking for a common denominator, the easiest way to do it is multiply the denominators, because what you're looking for is what will both 8 and 5 go into. So I know probably a lot of you, it's pounded into your head, you have to have the lowest common denominator. No, you don't. You just have to have a common denominator. You may have to reduce later, but as long as you get a common denominator. So the way you do that is you just multiply. 8 times 5 is 40. So what you're doing is you are renaming. That's all you're doing, is you're renaming the fraction. The way we're renaming it is you multiply the 8 by 5, which means I have to multiply the top by 5. Here is your multiplying by 1. So again, all we're doing is we're changing the value of it. So you're, in essence, going backwards. Instead of having like the 6/8 and reducing it to the 3/4, now you're having the 1/8 and you're increasing it to 5 out of 40. Okay, and then same thing here. The 5 needs to be multiplied by 8. So we're going to multiply top and bottom by 8, which is 1. So this becomes 2 times 8 is 16. So 5/40 plus 16/40. All you do is add the top. 5 plus 16 is 21. Now, the reason that you don't add the bottom is because, remember, the bottom is the total number of parts. That's why you don't add the bottom. The bottom is always going to be the total number of parts. So that's what makes it a whole. So 40 over 40 would be one whole unit. Okay, so that's number 10. Let's go to 13. And stop me for those of you on Zoom, stop me when if you have a question. Thank you guys all for your condolences. That's very nice. Okay, 2/9 plus 2/3. Okay, now, because I just told you this, we're going to do it the same way. Remember, there's different techniques in everything that we do in math. You need to find a technique that works for you and you need to stick with it. All right. So again, if I wanted to, I could just multiply these. 9 times 3 is 27. And I'll show you a different way to do it. So I multiplied the 9 by 3. So I get 6 27ths. I multiplied the 3 by 9. So I get 18 27ths. So 6 plus 18 is 24 over 27. And now I'm going to reduce it. So what goes into both 24 and 27 evenly? Yep. So we're going to divide top and bottom by 3. So I get 8 out of 9. Okay. So when I say it doesn't have to be the lowest common denominator, it really does not, excuse me, have to be the lowest common denominator. But I can do this same problem and go, okay, well, I know 3 goes into 9. So if 9 is my common denominator, the first one doesn't change. This one I can multiply by 3. And then I get 8/9. So either way, you will get the right answer. So sometimes you're going to see, you're going to see the common denominator right away, and other times you won't. And so it doesn't matter. Don't panic. If you can't see a common denominator, just multiply the values together, and then you'll be good to go. All right. Okay, so that's, okay, well, I better do number 11. All right, so that is adding. Subtracting is exactly the same thing. So on number 11, we have 7 3/5 minus 1/2. And again, there's different techniques. We can get a common denominator of the fraction and then subtract the whole numbers and then subtract the fractions. Sometimes that causes a problem. You can see it. Sometimes that causes a problem because you may have to borrow. So borrowing is always going to be a big issue. So the way I prefer to do this is I will change my mixed number into a improper fraction. So the way I do this is I multiply and then add. So 5 times 7 is 35 plus 3. So I get 38 over 5 minus 1/2. So anytime you have a mixed number, the way that you change it is you multiply the denominator times the whole number and then add that answer plus the top. And then the denominator always stays the same. Okay, so now I can get my common denominator. So I'm going to multiply. So 5 times 2 is 10. So I multiplied the 5 by 2. I'm going to multiply the top by 2. So 38 times 2, 16 is 76. And then I multiplied the 2 by 5, multiply the top by 5. And now you can see I can subtract very easily. Okay, and this is a great answer. It's a great answer. You do not have to always change an improper fraction back to a mixed number. You can if you choose to, right? So if I did that, 71 divided by 10. So 10 goes into 71 7 times. And I have 1 left over. So 7 and 1/10. And you'll get really good at this. This part right here, you don't ever, you will get to the point where you don't have to do this. I'm just doing it so you can see what the thought process is. When you get to the point, you can go, okay, 10 goes into 71 7 whole times with 1 left over. And then remember, you can always double check that you did it right. Go back to changing a mixed number to an improper fraction. 10 times 7 is 70 plus 1. There's my 71 over 10. So either of these answers are correct. I will accept either one. If in the back of your packet, it has 71/10 and you have 7 1/10, those are the same answer. So it's not incorrect to do it that way. Okay. All right. So that's adding and subtracting fractions. So adding and subtracting, you have to have a common denominator because you have to deal with the same size pieces. Okay. When we are multiplying, yes, go ahead, Yahira.
I have a question for the mixed number, the 7 whole number, and then 3/5.
Okay.
So you were saying how we have to add, do we multiply or do we add the 7 to the 3?
So what you're going to do is you're multiplying the denominator times the whole number.
Okay.
5 times 7 is 35. And
Yes.
then you're going to add 3 to that.
Oh, okay.
Because that's how many parts are left over.
Okay.
Yeah, so
That
that's how I
makes
got.
Okay.
Yeah.
Thank you.
Thank you for your question. And please don't ever feel like your question isn't valid, because I guarantee you, if you have a question, somebody else does too. 100% somebody else does too. So, and it's always good, even if someone else doesn't have the same question, it's always good for them to hear, get it verified that they're doing it correctly. So never hesitate to ask a question. Okay. So now we're jumping into multiplying and dividing. So let me try to do this. Did we get to multiplying and dividing on Tuesday? We didn't get there. Okay. 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 All right. So 4 9ths. All right. So on number 4, I'm just going to do it here. I'll try. Okay. So when we're multiplying and dividing, what we're going to do is we're going to change the division to become a multiplication problem. All right. So on number 4, what you're going to do, so there's 2 techniques. The first technique, write it up here. The first technique is to, there it is, Haley, good. Copy, dot, flip. I was trying to remember that on Tuesday and I couldn't remember the saying. So with multiplication, there's 2 different techniques. The first technique is you multiply, then you reduce. Okay, the second technique is you reduce, then you multiply. So you can see it's exactly the same thing. It's just the choice of order that you do it in. All right, so let me do the first technique first. So the first technique is I'm going to multiply straight across. 4 times 3 is 12. Multiply straight across. 9 times 16 is 144. And then I have to reduce, right? So I know 12 times 12 is 144. So 12 goes into itself. So what I'm doing is I'm dividing by 12. So 12 goes into 12 once. 144 divided by 12 is 12. So it's 1/12. That's the first technique. The second technique is what I prefer, because when I look at the big number 144, I don't panic, but it's just like, oh, I know an easier way. I know a way that's not going to make me deal with big numbers. So this reducing first, this is called cross canceling. And it's the cross part is it's any top. So any top with any bottom. That's what you're cross canceling. And what I mean by that is that's what you're reducing. So 4, let me get a different color pen. 4 goes into itself 1 time. So notice I cross out the 4 and I put my answer. And then 4 goes into 16 4 times. Okay, so I've just reduced it. And now I can reduce the other way. 3 and 9. So 3 goes into both of those evenly. So 3 goes into itself once. 3 goes into 9 3 times. And now I've reduced it. So now I'm going to multiply straight across. So 1 times 1 is 1. 3 times 4 is 12. Look at there, exact same answer. Okay, and that will work every time. And it keeps you from having to deal with big numbers and reduce big numbers. So that's why I prefer that technique. Another way to look at it, move this over here, is, okay, we did do this. I just remember. Yeah, okay. So if I have, let's see. I'm trying to make it so that it works. Let's see. Okay, so let's say I have this big problem, right? If I use the first technique and multiply straight across, 25 times 7 times 14, big giant number. 49 times 35 times 20, big giant number. And then I got to figure out how to reduce it. Like, what number can I reduce it? Now it's going to be a lot of process to reduce it. If you use the second technique, remember, it's any top with any bottom. So I can go, oh, 7 and 49. So 7 goes into itself once, 7 into 49, 7 times. Okay, and always cross it out. That way it keeps you from getting confused whether you used it or not. All right. And then, oh, look, I can do 25 and 35. So 5 goes into 25 5 times, 5 goes into 35 7 times. And then I can come here and go, oh, 14 and 7. Now, they don't have to be, let me erase this. They don't have to be, oops, right next to each other. I can do it this way. So this was 49 and this was 7. I can go, oh, look, 14 and 49 have the same common denominator, or have a common value. I can do 7 goes into 14 twice. 7 goes into 49 7 times. And then look, I can cancel the 7s here. So 7 goes into itself once, 7 goes into itself once. And then 5 and 20, I can cancel these also. 5 goes into itself once, 5 goes into 20 4 times. Now, when I look, I go any top with any bottom. So I have 1 over 1, 1 over 7, 2 over 4. Well, look, any top with any bottom, I can cancel the 2 and the 4. So you can keep going until you can't go anymore. Now, once they're all reduced, then you know you don't have to reduce. Your answer is going to be the lowest common denominator, or the simplest form. You don't have to reduce it anymore. Okay, so any top with any bottom, it can be in the same fraction, it can be right next to each other, or you can skip a fraction. As long as there's one top and one bottom, you're good to go. Okay, it just makes life so much easier, because you would have to work a long time to reduce that. All right, here we go. So let's see. Kaylee, you were the one. It was, oh shoot, I got to look at it again. See, I can never remember this. Copy dot flip. Copy dot flip. All right, so we're going to copy the first one, multiply, flip the second one. So copy the first one, dot means multiply, and flip the second one. So whatever is after your division sign, that's what you're going to flip. All right. And then I look and I go, okay, any top with any bottom, can't cancel anything, can't cross cancel. So when I see that, I know it's already in the reduced format. 9 is 3 and 3, 2 and 4. Yeah. So this is my reduced answer. If I want to change it and make it into a mixed number, you can. I actually prefer leaving it, as long as it's reduced, leaving it top heavy, just in case I have to use it again. And it saves you a step. Okay. All right, we'll do a couple more, and then we're going to jump into word problems. Let me look at our schedule real quick. So any questions so far? Okay, fractions are Tuesday. Okay, we'll get into the proportions. All right, we'll just do a couple more. All right, number 9. Whenever you're dealing with multiplying or dividing, you do have to change it to an improper fraction. Okay, so here's how you get to practice. So 1 times 9 is 9, plus 4 is 13 over 9. 4 times 2 is 8, plus 1, so that's 9/4. So I'm going to flip 4 over 9. Okay, so you do have to change it to an improper first, and then flip it and multiply. And then I double check, is there anything that I can cross cancel? No, so I'm going to multiply straight across. So 13 times 4 is 252 over 81. And that's it. That's all I can do. Okay. So if you've already done your homework and you've turned it in, just go back, like I said, go back and take a look at it. Read my comments, and then on the actual document. So you'll have to open up your document and take a look at it, and you can see comments on the document that I made. And then you'll fix it on your paper, and then you'll have to resubmit it to improve your grade. Okay. All right, we good? Okay, so some of the applications. Oh, yes, go ahead, you hear it?
Oh, sorry, that was an accident.
Oh, okay. Well, I'm glad you're here. Okay, so with applications, so word problems are something that a lot of people are scared of. So, and I was one of them. So how I conquered my fear of word problems is I realized that my job really is the only job that I can think of that I am handed a worksheet and I get to do the problems on the worksheet and get paid for it. No other job are you going to get a worksheet and do problems and get paid for it. You're going to be told a scenario, you have to fix it, right? You have to figure out a problem. So that's how you have to look at word problems. It's like, you know what, this is the reality. I'm going to be given a word problem. I'm going to be given a situation. I have to go, okay, mathematically, how is that situation going to lay out? So, so if you kind of look at it that way, so there's a few strategies. What I do is I read the whole thing just to kind of get an idea of what I'm looking for. I identify what is it that I'm finding. And then I identify like key terms. So Dolores sold candy to the pound by the pound. First person came into her store, bought 2 1/4 pounds of gumdrops. Second person came into the store and bought 5 3/4 pounds of jelly beans. How many pounds of candy did Dolores sell to her first 2 customers? So when you look at that, keyword, how many pounds, right? It doesn't ask for what's the difference. It doesn't ask for who got more. It asks for a total, right? A total. So when you see that it's asking for a total, you're going to find a sum, which means addition. Okay, the total amount. So now we know how to set it up. 2 1/4 plus 5 3/4. Now, this is a great example because my denominator is already the same. I don't have to do a whole lot. I can add the whole number with the whole number, and then the fraction with the fraction. Right? So 4/4 equals 1. So this is literally 7 plus 1, which is 8. So there's 8 pounds that she sold total. Okay, now if you want to do it the other way, if you want to be consistent, you see a mixed number, you go, okay, I'm going to, change it to a improper fraction. We can do it that way too. 4 times 2 is 8 plus 1 is 9 over 4. 4 times 5 is 20 plus 3 is 23 over 4. 23 and 39 is 32 over 4. When I reduce that, I get 8 pounds. So either way works. Again, you guys figure out which technique works best for you and then stick with that. And if you go back and forth, that's actually kind of improving your process understanding. But if you want to just stick with one technique, that works too. Okay, now what you're gonna find in this class is I am not gonna do every single problem in the packet. The fact that you guys have all the answers, you can practice as much as you want because that's what's gonna make you a really good math student is the practicing. So if anything in here is not done and you're like, oh, I need more practice on word problems, go back and do them. And then check in the back and you'll see that it's correct. Or if it's not, then you can figure out why. Okay, we'll jump to 20. Dennis's new, oh boy, of course I picked this one. Dennis's new dog weighs 127 3/4 pounds. That is a big dog. His friend's dog weighs 94.5 pounds. How much more does Dennis's dog weigh than his friend's dog? So this terminology right here, what do you think you're going to do with this one? So how much more means subtract? In other words, another way to say that is what's the difference, right? Difference is the answer to a subtraction problem. Good, Kels or Kaylee. Okay. All right. So do we subtract 94.5 from 127 or 127 from 94? Because this is important, the order that you put it. Okay, you hear it says, and Kaylee says 127 minus 94. That is correct. All right, so we're going to go 127 3/4 minus 94 1/2. Okay, so again, so here is where you know the whole borrowing thing is going to be an issue. If I change 1/2 to the common denominator of 4, this becomes 2/4, right? Well, I can't take 2 from 3. Oh, yes, I can. Sorry. 3 from 2. I can do that. Okay, so we're good. So we're going to subtract the whole number by the whole number. So 127 minus 94, 7 minus 4 is 3. 12 minus 9, 9, 10, 11, 12 is 3. And then 3 minus 2 is 1/4. So 33 1/4. So again, showing a different technique. I can do the improper fraction. Calculator out so I can do it quickly. So 127 times 4 is 508 plus 3. So this one is 511/4. And then 94 times 4 is 376 plus 2. So 378 over, and I did 4, right? Yeah, over 4. Okay, so then 511 minus 378 is 133. Divided by 4 is 33 1/4. So either way works. If you would prefer to change it into improper, just in case there's a borrowing issue, you can do that, or you can subtract the whole number by the whole number and the fraction by the fraction. Okay.
So we changed 1/2 to 2/4 because that is.
Yes, because we're subtracting, we need to have a common denominator. So this was 1/2. We multiplied by 2 to get 2/4. Yeah. Okay, why do we change the 1/2 to 2/4? Okay, got it. Yeah. So again, subtraction and addition, you have to get a common denominator. Multiplying and dividing, you do not. And so that's a big difference between the 4 operations that you have to really keep track of. Okay. All right, here we go. Number 22. Jerry bought 12.5 pounds of candy to share with his friends. If he gave 2.5 pounds each to 3 friends, how much candy does he have left? So when you look at this, you go, okay, we have a total. He's giving away 2.5 pounds to 3 friends. So we have to figure out how much total he gave away. And then we have to figure out, all right, how much is left? So there's 2 or 3 steps that we're gonna do. So Kaylee says divide. So what do you guys say? With someone else. We'll see if Kaylee's right or not. What would you do? Okay. Okay, good. So Yuritsa says multiply the 2.5 by 3 because you can see it this way. You have 2.5, 2.5, oops, 2.5, and 2.5. There's your 3 friends, right? Here's 1, 2, 3 friends. So you can add the 3 together, or remember multiplication is repeated addition. So you can do it this way, or you can multiply by 3. So we have a mixed number. So in order to multiply, you have to change it to an improper. So 3 times 2 is 6 plus 1. So we have 7/3 times 3. Okay, so we have a whole number. This is our first time seeing a whole number. How do you multiply fractions with a whole number? What do you think? There you go. You divide it by 1, because remember, dividing or multiplying by 1 doesn't change anything, but it makes it look much easier to deal with. And then I see I can cross cancel. So 3 goes into itself once, 3 goes into itself once. So 7 times 1 is 7, 1 times 1 is 1. So 7 divided by 1 is 7. So we used 7 pounds. Okay. And so now we have to find out how much is left. And so we're going to subtract. So 12 and 1/2 minus 7. So now see, this is where, okay, we don't have a mixed number, right? We don't have anything to subtract the 1/2 from. So we can do it with a improper fraction. So 2 times 12 is 24 plus 1 is 25/2 minus 7/1. So again, now we're subtracting, so we have to get a common denominator. So we're going to multiply by 2, multiply by 2. So we have 25/2 minus 14/2. So 25 minus 14, is that 9? No. Is that 9? 5 minus 4, no, 11, sorry. Oh, come on, stop. So 11/2, which is the same as 5 and 1/2. Okay, everyone good? All right, so I'm going to leave that there. Here's your homework. And remember, in Canvas, it tells you which particular problems to do. You don't have to do all of them, but again, there's a lot left over for you to practice. So if you're like, you know what, I want to make sure I understand this, do them over and over and over again. I think you have 8 problems to do, and then turn them in and I will mark them off. All right, we good? Okay, so the fractions homework is due tomorrow. So for those of you, if you guys are in class, if you don't have it done, you're still free to do it and scan it and, you know, post it in Canvas tomorrow. Or if you want to turn it in today, you can turn it in today, okay? Whichever is easiest for you. Okay, and then our next section, let me show you, is percents. I have it plugged in, is percents, proportions, and applications. Okay, so what that means is, sorry if I'm making you sick, don't mean to be. Okay, so when we're looking at percents, proportions, and I think the third one was ratios. Yes, this is page 5. So now we're at the beginning of the book. Percents, proportions, and applications. Okay. So when we're talking about percents, a percent is literally a fraction. The percent is the value given always over 100. Okay, so that's how we get percents, is always over 100. Because, for instance, if you get a 92% on a test, what you literally got was 92 out of 100. You got 92 right out of the 100 questions, per se. Okay, so if you only take a 5-question test, and let's say you get 2 out of 5, to make that into a percent, how do we get the bottom to be 100? Well, we multiply by 20, both top and bottom. So again, there's that multiplying by 1. So that is a 40 out of 100, which is a 40%. Okay, so that's what a percent is it's just based out of 100, and then you can change it depending on what you get. You can change it. Now, another way to do this is if I got 2 out of 5, remember, fraction just means a division, just means division. So 2 divided by 5. So you can see it's not top heavy, which means it's going to be less than 1. So we're going to have to add a decimal and a couple zeros. We bring our decimal straight up, and then we pretend like that decimal is gone. And we just do our division. Okay, so 5 goes into 24 times. 4 times 5 is 20. We subtract, we bring down our 0. 5 goes into 0 times. So what happens when you do the division of the fraction, you end up with a decimal, right? To change a decimal to a percent, all you do is you take your decimal point and you move it twice to the right. So there's your 40%. So technically what you're doing is you are multiplying by 100. That's what you're doing. You're taking your decimal and you're multiplying it by 100. And that's why you get the 40%. So multiplying by 100 is the same as moving the decimal twice. Okay, so that's kind of the basics of percentages. Sorry. Okay, so what we're doing is we're looking for the parts in the whole, right? So we have a part and we have a whole. So remember, this is how fractions are always set up, right? When we had 3 out of 8, 3 was the number of parts, 8 was the total number in the whole, in that big circle. So when you're looking, you want to find there's some terminology that will give you, is it a part or is it a whole? So on number 10, it said, this is on page 7. Number 10 says, Tony tipped $8 on a $22.58 ticket. Okay, so a tip is just a part, right? So the part is $8. The whole is the total. So whole, another way to look at whole is total. Number 11 says, in an 82-game regular season, the Spurs won 58 games. So the part is 58, and the total is 82. So there's your what's called a ratio. You're comparing two things. Okay, NVC is number 12. NVC has 15,435 students. 4,630 of them will transfer to USA. So the part is 4,630 out of the total 15,435. Okay, so it's just a matter of looking at it and going, okay, what's the part, what's the total? Now, the reason for that is because then we can do what's called a proportion. So proportion, okay, this is still the prep. La, 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 don't need that, don't need that, don't need that for now. Don't need that, okay. So with the proportion, a proportion is two ratios. It's the part over the total or whole equals the part over the total. So for instance, here's where we use this. So let's say that at NVC, we have a ratio of 3 girls to every 5 guys. Okay, that's our ratio. We're comparing how many parts and how many girls, how many guys. All right. What we want to know is if there are 1,500 guys, we can figure out how many girls there are based on that ratio of 3 to 5. And it makes it's very, very easy to do. So whenever we're solving for proportions, you are doing what's called diagonal multiplication, kind of like cross multiply. So we're going to multiply diagonally. And what happens is this diagonal is going to equal this diagonal. So they equal each other. So 3 times 1,500 is 4,500 equals 5 times the number that we're looking for. And then we can solve it, right? We have a one-step equation that we can solve. So I want to get x by itself, so I'm solving for x. So this is showing multiplication because 5 times x. So what undoes multiplication? Division. So I'm going to divide both sides. So x equals, and then 45 divided by 5 is 9, so 900. So what that means is there's 900 girls. So based on a ratio, we can set up what's called a proportion. And a proportion is when you have 2 ratios together with an equal sign. You can solve for anything. You just need 3 out of the 4 values. And it doesn't matter where on those 4 positions, where the variable is, you can solve it in any way. Okay. All right, so let's try a couple of these. So look at number 29. Okay, so go ahead and diagonally multiply. So you multiply this way. So this is on, did you find the right page? Okay, page 10. So 7 times 60 is 420. And then we're going to diagonally multiply this way. 20 times x is 20x. Okay, so now we have a one-step equation. Now, just remember, it doesn't matter which way you multiply first. I could have multiplied 20 times x and then 7 times 60. You can see these are exactly the same thing. They're just 2 values that equal each other. What you want to be careful of is if it's set up this way, I want the x by itself. So I'm going to divide by 20 on both sides. If I do it the second way, again, I want the x by itself. So you always divide by the value that's next to the x. So either way, my x is going to be 2210. That's right. 21, sorry. No 0. So 420 divided by 20. Now I'm second guessing myself. 21, yep. Okay, so here's a great thing. Here's what I just did. And I want you to always know that your answer should make sense. So let's say I got 210. Can anyone tell me why that's incorrect? What would give it away? Yeah, 20 times 210 is way bigger than 420. Also, did you notice the 7 is smaller than the 20? So the top number over the 60 should be smaller than 60. Because they're equal, they should have the same ratio. So that's how you can tell your answers whenever you're doing math, your answers should always make sense. Every single time they should make sense. Okay. So always look and go, okay, does that make sense? Does it look like the ratio is the same? So 7 over 20, 7 is smaller, 21 over 60, the 21 is smaller. So yes, it does make sense. Okay, now here's another way to check. What do you multiply the 20 by to get 60? If I do the same thing, right, multiplying by 1, 3 over 3, look, here's my 21 over 60. There it is right there. So that's another way. If it multiplies evenly, you can do it that way too. You can go, okay, what do I multiply the 20 by to get 60? Can I do the same thing? Now, that's a good way to check. I would not recommend that you do that with every single one, because if you look at number 30, what can you multiply 75 by to get 100? Well, you can't. So this technique only works when it's even values, right? When there's a number that you can multiply by. But the cross multiplying technique works every single time. So on number 30, 75 times x is 75x. And then 42 times 100 is 4,200. And then because I want x by itself, I'm going to divide by the 75. So x equals 56. Okay, and then I just kind of double check. 42 is less than 75, 56 is less than 100, so we're good to go. Okay. All right, so what we're going to do, so for those of you on Zoom, I want you to do 31, 32, 33. And then in the chat, go ahead and put your answers in. And then for you guys, go ahead and do those 3 and we'll check our answers in a minute. Any questions? You guys good? Did you check your answer?
Once you get your answer, you know, it's hard to remember the check.
And you're good? All.
Oh, okay. Oh, so this one, oh, yeah. Yeah, so it's the exact same thing, so even though this one has something about. This one, it doesn't matter. Or maybe yeah. So you like looking for it. Oh, really?
And I didn't get to talk to the manager of the math lab, but I will talk to him tomorrow about the calculators. So these you can buy like Target, Walmart. They're like $15 and they're solar, so you don't have to worry about batteries. They're really nice. It's the TI-30XS, and this one works great. So if you want to have one in your hand, that's a good idea because you can't use your phone on the test. So, yeah. Okay, so we got answers. Okay, so Sophia. Okay, so even on people on Zoom, remember with your packets, you can look in the back. Look in the back and see at the very back of your packet, there's the answer key. And they do it by page number, I believe. And we're on page are we on? Something like that. So you can always check your work. 31. There it is. Okay, so 31, you should have got 20.4. 32, you should have got 4. And 33, you should have got 3. So let's try it. All right, so again, it does not matter where the variable is. This technique works every single time. I love this technique. What's 30 times 3.4? Someone help me out.
102.
102, okay, divided by 5. What did I say it was? 20 something. Huh? Yep, 20.4. Okay, and then this one, same thing. 35 times x is 35x. 14 times 10 is 140 divided by 35. So x equals, what's that? 4. Okay. And then this one, same thing. X times 133. And then 19 times 21 is 399. So x equals 3. Okay, so any questions? You guys good? Feel confident? Good. Okay. All right. So now what we're going to do is we're going to apply all of this. Okay, so this is your definition of a proportion. It means 2 equal ratios. So a ratio is just a comparison. You're comparing, boys to girls, dogs to cats, people to animals, whatever it is. And then when you set 2 ratios together, then you can always cross multiply. Okay, so let's see, what are they showing? I do not like this technique. This is not the technique that I would use. Oh, that's funny. Yes, go ahead, Yahira.
Sorry, could I see the answers for 31, 32, and 33 again? I had went to the bathroom and I didn't get to see the answers.
Yes. So Yahira, in the back of your packet, there's the answer key also.
Okay.
as you're doing your homework, you can check as you're going, which is nice because then you can
Okay.
track. So 31 was 20.4, 32 was 4, and 33 was 3.
Okay, thank you.
All right. So this is another technique. I'm not a fan. It's not that it's any harder. They're just they are cross multiplying. 21, 5 times 12, that's where they get this. And then they're dividing by 6. So I don't like that technique. I like my technique so much better. Okay, here we go. So percents. So there are some key terms that will work with a proportion every single time. So if you always set it up, is over of equals your percent over 100. Here is your proportion. The part, that's an S, by the way, the part over the whole, and then percent over 100. This is how you're going to set these up just about every single time. We're on page 13, section B. So I'll rewrite it. Is over of equals the percent over 100. And you will never get these wrong. And then you use that diagonally multiplying technique. Okay, so here we go. What is 35% of 100? Okay, so here is your of, and you can think of it as like out of 200. I said 100, out of 200. So there is your of. The 35 is your percent. And because it's a percent, that's where it goes over 100. So 35% is the same as 35 over 100. So what you're looking for is the is. There's where your variable goes. What is your is? Of is your 200, and 35 is your percent over 100. And then you just diagonally multiply across. So 100x, and then 35 times 200 is 7,000. And then you're going to get the x by itself by dividing both sides by 100. So x equals, let's see, we have 2 zeros cancel. 70 divided by 1 is 70. Okay, and again, you can double check, right? What did you divide the 200 by to get 100? Well, you divided by 2. So if this is 70, what's 70 divided by 2? There's your 35. So just a quick way to check, to double check that you've done it right. It's just an easy way to make sure that your math is correct. Okay, so let's try this one. I'm going to do a different color. Let's try this one. 35 is your is. What percent of 200? So 35 is your is, of is your 200. The percent is what we don't know. And you can use any variable you want. If you want to make it easier on yourself and you want to use a variable that makes sense, you can use P for percent, but whatever you want to do. So here we go, diagonally multiply. 200 times P, and 35 times 100 is 3,500. And 3,500 divided by 200. So P equals 17.5. Now remember, the 17.5 is the percent because that's over 100. So you don't have to move decimals. That's why I love this technique, because you never have to move a decimal. The value that you get for the percent is the percent. So it's 17.5% is what 35 out of 200 is. So if you took a 200 question test and you got 35 questions right, that would be a 17.5%. Okay, So, and what's nice about this is it doesn't matter what the variable is. As long as you have 3 out of the 4 numbers, then you're good to go. All right, so 25 is. So we have 25 is there is. Of is what we don't know. And we do know that 40%. So once you get the setup and you get that setup down pat, then it's just a matter of diagonally multiplying and solving. So 20, did I do that right? 2,500 divided by 40 is 62.5, right? So that makes sense. 25 out of 62.5. So 25 is less than 62.5 and 40 is less than 100. Okay, so that makes sense. So any questions on that? How to set those up? All right, so go ahead and do 6 and 7. So same thing, you Zoom people, go ahead and put your answer for number 6 and number 7 in the chat. And then just so you know, Monday is a holiday. And then Tuesday is when the percent proportion and application homework will be due. So after today, you'll be able to get that done and you can send it in early or send it before midnight, 11:59 on Tuesday. And then you guys can bring it in on Tuesday and just hand it. Okay. So what I do is I just look for the terms, right? And whatever value is next to the term, that's where I know it goes. So 19.5 is 15%. And we are looking for the of. So again, is over of equals your percent over 100. Yeah, so you had asked if you move the decimal over twice. The only time you do is when you're changing a decimal to a percent. So in these, because it's out of 100, you never have to change the decimal. It's only when you like divide a fraction and you get a decimal answer. Okay, so Sophia says number 1 or number 6 is 130. Everyone agree with that? Yeah, Okay, so we got x equals 130, good. Okay, and then this one, 35 is your is. 15%, so the percent will always go over 100. And then the of is what we're looking for. Okay, so x is going to be, anyone got it yet? You have it?
I got 233, but.
Okay, are you confident in that answer?
Not crazy confident, but it's just what I thought.
Okay. So did you set it up correctly?
Oh, yeah.
Okay. Okay, and then did you multiply and divide correctly? Okay, then be confident in your answer, because that is correct, yes. Yeah. That's something that a lot of students struggle with, is just that second guessing. So what you have to do is you have to go back to, do I trust the process? If you did the process right and you did the math right, then you're good. Just be confident in your answer. Yeah. Okay, good, Sophia. And Emma and Yahira, very good. Okay, so you guys good with those? All right, so now let's look at some proportions to set up and applications. So we'll do a couple of these and then so I guess I should ask you guys, are you more desirable of just going straight through, no breaks, and getting out a little early? Or do you feel like, nah, I need a break in the middle? What do you guys think? You don't need a break? Okay, you're not like eyes crossed with too much math. Okay, all right, everyone okay with that? Okay, all right, so we'll just keep on going. And so what that means is we'll probably done about 11:45, because I always like to give 10 to 15-minute breaks, because 2 hours is cruel and unusual punishment sometimes. Okay, okay, so we got that, we got that, we got that. All right, so let's set up a couple proportions and then solve them. So again, it's not always going to be percentage problems. So those are the types of proportions for percentages. Sometimes you're setting up two ratios. So remember, proportion is just two ratios set up. So you're looking at comparing values. So Joe's heart beats 11 times in 10 seconds. At that rate, how many times does his heart beat in 60 seconds? So what you're going to be given is, you're given a known. So you know it's going to be 11 times. And I'm going to write down what the 11 means, because it helps in the setup, in 10 seconds. Okay, so that's a comparison. It beats 11 times for every 10 seconds. We want to know, how many times does it beat in 60 seconds? So here's some things I want you to keep in mind. Whenever you're setting up a proportion, you have to have the same measure top to bottom. So in other words, I wouldn't do this. I wouldn't change it and write it this way. So don't write this. I wouldn't do 60 seconds in X times. Do you see how the 60 seconds is on top here, but times is on top here? So you always, always, always want to make sure that the way you set it up is going to be super important. We're looking for, how many times does it beat in 60 seconds? Okay. So now you're good to go. You have 11 over 10 equals X over 60. Same exact technique. And that's why I love proportions, because once you set it up, the technique is the same. It's never going to change. It's always going to be diagonally multiply and then divide. So 10 times X is 10X. 11 times 60 is 6,600, or 660. And then dividing both sides by 10. Good, Emma. Okay, so here we go. One plain bagel has 320 calories. How many calories are in 2.5 bagels? So your ratio is 1 bagel for every 320 calories. We want to know how many calories are in 2.5 bagels. So they've given us the number of bagels. So that's going to go on top. What we want to know is how many calories. Okay. Now, you can switch this if you want. You can do 320 calories to 1 bagel equals how many calories to 2.5 bagels. It doesn't matter what goes on top, what goes on bottom in the initial setup. What you want to make sure is that you have the same measure top to bottom on both ratios. Okay, and then we have our proportion. So 1x, 1 times x, and 320 times 2.5. So 800. So if I'm keeping the same technique, just remember 1 times x is the same as x equals 800. So I don't even have to do anything else with it. So in 2.5 bagels is 800 calories. You know those, do you guys ever go to Costco?
No.
The muffins? Oh my gosh. I used to love the almond poppy seed muffins. One muffin is 1,200 calories. Yeah, they don't tell you that.
Used to like.
And then I go, oh, I'll only eat half, but then I eat the whole thing. They're so good. But I couldn't believe it. It's like,
That
oh,
never works.
no, no, no. So then the other philosophy is just don't look. Don't care, whatever. I like it. Okay, so number 13. Oh, so far so good. Everyone okay? Kaylee, you're hearing Kaylee say, yo, man. Yeah, I know that ruined them. And then the chocolate ones, like with the chocolate chips in them. Now I'm hungry. Those are even worse. But that's why they're so good. I did just see RFK Jr. did a speech and he was talking about the health of America, and it's like one of his passions, and he's really wants to figure it out. They have data that in the 70s, 1 in 2,300 kids had autism. That was in the 70s. Now it's 1 in 36. It's very common. And so his question is, why? What is it that we're supposed to be a healthy nation and we're one of the worst nations? It's the food. Yeah, it's what they put in the food. All the, chicken nuggets and all those preservatives and all of it. And they said in California, it's 1 in 22. And the California is where all the beautiful, beautiful people live. Supposed to work out and everything in California. So, yeah, and that's one of his things that he wants to work on is, let's fix this. This should not be happening. Yeah, it's interesting. Okay, number 13. Leaking pipe can lose 24.7 gallons of water in a week. How many gallons are lost in 30 days? So we're going to do 24.7 gallons. Now, here's where we got to be careful. And this will catch you every time. And then how many gallons are lost in 30 days? So what's wrong with that? What's the problem? Yeah, you have to have the same units of measure. Okay, you have to have the same units of measure. Good. Convert the week to days. Now, you could convert the days to weeks, but if we look at it as 7 days as a week, we have 7 plus 2 more days, right? So it's actually easier to change 1 week to 7 days. If you change the 30 days to 4 point something days, your answer will be skewed just a little bit. So this way it'll keep the answer better. So always double check. The units of measure have to be the same. So like if they said we lost 24.7 liters in 7 days and how many gallons, then we have to do some other changes. Okay, so here we go. So 7 times X, and 30 times 24.7 is 741. So X is going to equal 105.857 gallons. So almost 106 gallons. I left my hose on accidentally. This was during the drought last summer. Yeah, it was not good. They actually came to my house and said, so we want to check because you've had 20,000 gallons that you used this last week. It's like, oh, yeah, that'll never happen again. Okay, last thing, we're going to do applications. So these are a little bit different. These are not necessarily ratios. So we're going to use these two equations. Okay, so definitely have these in your notes. So that when you take your test, you have your notes and the formulas. So the first one, this one is looking for total price. So the idea is you go into a store, you buy a shirt, and the shirt costs $15, right? You go up to the register and they say you owe $18.25. What's the difference? Why the uptake or why the higher price? Because of taxes, right? So you have to get the tax rate into the total price, right? So the way that you do that is you take the price. So in my example, you take the price, which was $15 plus, and you're adding to that the tax. So how do you find the tax? You take the price and you multiply that by whatever the tax rate is. So if the tax rate is 8.25%, right? We can't multiply 15 times 8.25%, but we can multiply it by a decimal. So 0.0825. So what you're doing is you are dividing this number by 100. And dividing it moves the decimal twice to the left this time. Okay, so you take whatever the percent is and you divide it by 100, and that gives you the value that you can use. Okay, so the price plus the tax gives you the total price. So that's the idea behind that formula. Okay. So let's do a couple of those and then we'll go back to the second one. All right, so Amy bought a pool hall for $219,765. This price includes the 5% state tax. What was the price of the pool hall before tax? So this is where when you read a word problem, you got to go, okay, here is my formula. Let's put in the values where they belong, right? So it says that this price includes the 5% state tax. So is this price the price or is this the total? That's your total. So you're going to put the total in where it belongs. Good, Kaylee. Okay, the 5% is your tax rate. So we're going to do that as 0.05 because remember, we're moving the decimal twice to the left. what was the price? This is our unknown. Okay, so we have our unknown plus our unknown times the tax rate. So out of the way. All right, I need to write this better. Okay, so it's the price plus 0.05 times the price equals 219,765. Okay, so do you remember what number is in front of this X? If there's no number there, what number is it? So 1, always a 1. So now we have what we call like terms. We can add these two. 1 plus 0.05 is 1.05x. Okay, so if you ever have an unknown and there's no number in front of it, it's a 1 because 1 times x is x. So now you're right back to a one-step equation. We're going to divide both sides by 1.05 to get that x by itself. $219,765 divided by 1.05. Okay, and again, with math, it should always make sense. Every single time it should make sense. So if you look at this 209,300 is less than 219. And so your price will always be less because you take the price and then you add the tax in. Okay, so this is our price before tax. So this is like that $15. So I'm going to ask an additional question. How much was paid in tax? How would you find that one? Yeah, you would subtract them. Take the total minus the price, and you get your tax. Huh, not painful. Oh, 19,000, sorry, 19,000. So almost $20,000 was paid in tax. So just so you know, I try to apply this to life. If you buy a $30,000 house, a $300,000 house, you pay on it for 30 years, you will have paid about $200,000 in tax, depending on what the interest rate is. Yeah. Same with student loans. Please, please, please. You guys are literally doing the whole college thing right. Because if you start now going to university and you have to get a student loan, then you're getting student loans for 4 years. You guys may or may not even have 2 years of student loans. But don't get student loans. Even if you have to go to college for 10 years, that is so much better because there's people that are in their 50s still paying on student loans. It's ridiculous. So I can go on my soapbox on student loans, and I'm living it right now. So it's not good. All right, so let's try the second one. So the second one is called a percent of increase or decrease. So where this one comes into play is, so you guys, were you even driving? You were driving 4 years ago, 5 years ago. Do you remember what you paid in gas?
Oh, it was around COVID. Was it COVID time or was that?
Even before COVID. Without being political, it was about, I was like in heaven. It was about $1.69, about 4 or 5 years ago. Yeah. And now it's $2.99, around $3, right? So this percent of increase or decrease question is, okay, what percentage did it go up or what percentage did it go down? If the percentage went up, it's a positive number. If it went down, it's a negative number. So that's how you know increase or decrease. So if it was $1.69 and now it's $3, obviously that's an increase, right? So it's a really easy way to compare values. You know, you can ask yourself, was my life better before or after? Right? There's all those questions. And just to make you guys feel so much better about yourself living in Texas, in California, they're paying almost $6 a gallon. $6 a gallon. It's crazy for the exact same type of gas. The big difference is in California, they add what's called an environmental tax on top of it, which we don't pay. And you go into LA and it's like one of the most smoggiest places you've ever seen. And you go, I thought you had like better gas there. And clearly it doesn't work. And then this just cracks me up. You're gonna feel where I'm coming from and why I'm so happy to be out of California. Because they're really pushing the whole green energy in California. They're requiring people to buy electric cars, and they're saying by 2030, they're saying everyone's going to have an electric car, including diesel trucks. And so businesses are leaving in droves because one, they can't afford an electric car or electric vehicle, and two, they don't go very far. Like you can't get from Kerrville to San Antonio Airport and back on one charge. You have to stop and recharge, even though they say it goes 300 miles, they don't. Anyway, so now because so many people are buying electric cars, their gas tax isn't covering what they need. So now they're trying to pass a law that they're going to tax you on the number of miles that you drive. So not only are people with gas cars going to get taxed on gas, now they're going to get taxed on how many miles you drive to go to work and back. Because someone didn't think that one through. That, oh, if we make people have electric cars, now we are running out of money. Yeah, it's nuts. So when we lived there, we paid, my husband's an electrician, he has his own business. So we paid about 46% in taxes. So every $100 we made, 46 of it went to taxes in California. And here it's about 30%. It's much better here. So yeah, it's crazy. And you pay twice what a 2-3-bedroom house is about $5,000 to rent in California. It's crazy. Okay, here we go. We're almost done. Okay, here we go. Here's number 18. So this is a great example. Price of gas increased from $3.25 per gallon to $4.05 per gallon. What was the percent change to the nearest percent? Okay, so here's our formula. The new minus the old divided by the old. I'll write it down. The new minus the old divided by the old, and then that answer times 100. And that will give you your oops. There it goes. That will give you your percent increase or oh my gosh, what is going on? Percent increase or decrease. Okay, so here we go. So increased from 325 to 405. So which one's the new, which one's the old? Okay, there's the old. There's your new, from this to this. So you're going to go 405 minus 325. That answer divided by the old. So get that answer first. 405 minus 325. So that is 0.8 divided by 3.25. Equals 0.24615. And then that answer multiplied by 100. And really all that does when you multiply it by 100, all that does is it takes the decimal and it moves it. See, the decimal was here, now it's here. So it just moves it twice. So this multiplying by 100, just remember you have to do it, but you can do it visually just by moving the decimal. So this was a 24.6%. And because it is a positive number, it's an increase. 24.6% increase. Okay. Yeah, I agree with all of you. It is dumb, California. And it's a beautiful state. That's what's sad. It's beautiful. And oh yeah. Yeah. It's going to be interesting what they do because the next Olympics is in LA and they're going to have to clean everything up. They're going to have they have so much homeless there and it's yeah, there's tent cities everywhere. It's gotten very ugly. It's very sad. So we'll see. All of a sudden, old Newsom will clean up, do what he spent $10 billion to do. Okay, we're gonna stop there. That should do it. That you guys have an example of everything that you need for your homework. Is there any other questions? Feel good about it? Not too bad? Yeah, go ahead, you hear it.
My question was for our self-reflection that we have to turn in. It's gonna be my first time using the CAM scanner. Do we do like the self-reflection assignment like on a PDF, like on the computer, or do we just like write down the answers like on a notebook?
You can do it either way. If
Okay.
you have a printer and you want to print it up and do your answers like that, or you can do it on a separate piece of paper. It really doesn't matter. Just make sure you keep it organized and numbered and all of that. And then
Okay.
if you have more than one page on the CAM scanner, you'll take a picture and then you'll see a plus sign at the bottom. And what that means is you're going to add a page. So you're
Okay.
not going to send in separate documents. You're going to send in one document but that one document can have several pages to it.
Okay. Okay, that makes sense.
Yeah, if you have trouble, email me and I can walk you through it.
Okay, thank you so much. Thank you, Kalea.
Okay, you guys have a great weekend. Be safe. And I will see you guys on Tuesday. Enjoy Monday. Monday is no school.